I could have died.
Alright, today we're going to take a look at solving systems using elimination. Okay, so we've already done wrapping and substitution. Okay, the third way that we're going to look at is elimination. And I think this way is the easiest way. Alright, so when we're solving a system using elimination, the goal is to eliminate one of the variables by adding the two equations together. To do that, most of the time we will have to multiply one or both of the entire equations by some constants. Okay, so what I mean by that, if I'm looking at these two equations, and my goal when I'm adding these two equations together is to cancel out one of the variables. Well, I can try to eliminate the x's, or I can try to eliminate the y's. It doesn't matter. But if I just think about adding these two equations together as is, well, 2x plus x would be 3x, negative y plus 3y would be 2y. They don't cancel out. Right? So I'm going to have to multiply one of the equations by some number. If I want to think about canceling out the x's, and again, you can choose either set of variables to cancel out. Sometimes one will be easier than the other. Right? So in this case, if I want to cancel out the x's, when I add 2x to this, I want them to go away, I can multiply this one by negative 2. Exactly. If I do that, though, I have to multiply the entire equation by negative 2. Every single piece of that equation. Okay? I have to multiply this by negative 2, this by negative 2, and this by negative 2. Okay, so what will happen then? This equation will become negative 2x minus 6y equals positive 12. So then I'm going to rewrite my top equation here. I have 2x minus y equals 9. So now, I want to think about adding these two equations together. If I just add straight down, 2x plus negative 2x is 0. Right? That goes away. That cancels out. Then, negative y plus negative 6y would get me negative 7y. And then 9 plus 12, 21. Yeah. So now, to get y by itself, to solve for y, I'm just going to divide both sides by negative 7. And I get negative 3. Y is negative 3. So now we also need x. So if I have my y, how am I going to find x? Yeah, take this and plug it into either of my original equations. Right? It does not matter which one you choose. Right? But we can do the first one if we want. So 2x minus negative 3 equals 9. So this would be 2x minus negative 3 would be the same as plus 3. Subtract this 3 over. 2x equals 6. Divide both sides by 2. And we get x equals 3. So it's kind of similar to substitution, especially the final step. Like once we solve for one of the variables, we'll have to plug it back into one of the equations to get the other one. So what is my final answer here? 3. Right, the coordinate point, 3, negative 3. Exactly. X, then y. So what we just found is that these two lines, remember these are just equations of lines, intersect at the point 3, negative 3.
Bam.
Bam. Any questions so far? Yeah. Okay. So let's do one more example together here. All right, so again, we want to use elimination to solve this system. And again, to do that, our goal is to multiply one or both of the equations by some number, by some constant, in order to get one of the sets of variables to cancel out. So if we look at this set of equations, is there one of them that I can multiply by one number in order to get, to get the variables to cancel out? No, right? I can't just multiply this one by 2 to cancel out the x's, or I can't just multiply this by 3 or something like that. In this case, I'm going to have to multiply both of the equations by a constant. Not even going to ask. Alright? Mike. It's not.
Keep going.
Alright, so in a case like this, where none of the variables are going to cancel out nicely, and I can't just multiply one equation by a number, I'll have to multiply both. It's usually going to be easier to look at the set of variables that has the smaller coefficients. Right? So in this case, I can look at the y's to cancel out. Right? Those have smaller coefficients than the x's. Right? That'll just lead to smaller numbers as I'm doing my calculations. So I know I'm going to have to multiply both of these by some number. How can I figure out what numbers I'm going to need to multiply by?
Or I mean, you could just look at the numbers and just put the opposite.
I think that's going to be the easiest way to
Plug
go.
each other.
Right? Yep. We're not going to plug it out. Okay? So, if I want my y's to cancel out, Kayla's idea is going to be the easiest one to go with. What I'm going to do is just multiply the opposite equation by a coefficient. Right? So, if I want these y's to cancel out, I'm going to take this top equation and multiply by this coefficient. So I'm going to multiply the top equation by 3. And then I'm going to multiply the bottom equation by 2. Now, yeah, so that's what I wanted to ask. Should this be positive 2 or negative 2?
It should.
It should stay a positive 2 because I already have opposite signs.
Oh, I see what you're doing.
But shouldn't the 3 be a negative?
Well, so if I make this one
Or
negative,
never mind.
this
Yeah.
would end up being a positive. Right? We want it to stay at negative. So since I already have opposite signs here, I just want to make both of these numbers positive. Right? If these were the same sign, if these were both positive, then I would need to make one of these coefficients negative so that they would cancel out. Okay, so let's see what happens then when I multiply these numbers through. So remember, I'm multiplying this 3 to everything here. So this will become 9x minus 6y equals 12. And then this one will become 10x plus 6y equals negative 50.
Easy.
Okay, so now I add my equations together. So 9x plus 10x, 19x, negative 6y plus 6y, that cancels out. And then 12 plus negative 50,
It's negative.
negative 38. Then we want to divide both sides by 19. And we get x equals negative 2. Now what?
We plug it into an equation.
Now we plug it back into one of our original equations. Which one?
Top.
Sure, let's use the top one. Again, it doesn't matter. But the top one has smaller numbers here, so let's use the top one. So I'm plugging negative 2 in for x, since I solved for x. So we get negative 6 minus 2y equals 4. Add that 6 over. Negative 2y equals 10. Divide both sides by negative 2. We get y equals negative 5. So what's my final answer? Coordinate point, negative 2, negative 5.
Okay, but that's what.
All right. Questions on this idea here? All right, then we're going to take a decent chunk of time here and try